Good day, everyone. This is a recording from our third lecture on BBER and BBER3712. So I want to start out with just a simple concept, which I've done with some of you during the course of last year and the year before, but a simple concept of adding your VAT. So it is very important to make sure that you understand how VAT is added to your calculations. By now, you should at least have this or a good understanding of how it usually works. So whenever we've got an apple and we take 15% off or out of this apple, we end up with a small apple. So it is not the same as when you have VAT included already. So if you've got VAT included, you already have a big apple and a small apple. And if you times that with 15% and then subtract it from your item that you started out with, you will not get the same answer as when you times it with 100 over 115, for instance, or 115 over 100. So the main thing is to make sure that you cannot just take a VAT inclusive amount and then times that with 15 and then subtract it from this again, because you will not get the exact amount when you do that. So VAT inclusive, if you take 15% of that, you will then get the VAT exclusive or inclusive and the little apple together. So just make sure that you understand this concept, that you should then rather use the previous calculation. If we just change 15% to put it over 1 over 100, we will get the same answer. So, but in this case, we've got 115 over 100, and thus if we want to take out the 15% out of that, it's 15 over 115 to get only the small apple, which is the VAT component. But if we want to take the VAT out of that to get a VAT exclusive amount, it is always 100 over 115. So just make sure that you understand this concept. Try it out. It can have big implications if you're working with large projects. So just be mindful of that. Okay, so getting to this week's theory and content that we need to cover, we're looking at the single price detailed methods. So last week we only looked at single price methods. So this week we're going to look at the single price detailed methods, which includes the elemental cost analysis method up to the elemental component. The next level of elemental estimation that we're going to focus on is up to component level. So make sure that you make the distinction between these two. So your story enclosure method is the second one that we're going to look at. And this is a bit more complicated one, where we're going to look at the factors and so on when we do these calculations. And then the last one is the parametric cost method, which I usually call the get out of jail free card. Whenever we press for time and we have to get a quick estimation out. So these methods is still quite simple, but more detailed methods of estimation than the previous ones. It doesn't take long to complete, and more accurate than the previous single price estimation methods. So getting into the elemental cost analysis method. So a major part of the building that has its own functional requirements, such as walls, floors, windows, doors, etc., is broken down. The building is just broken down into more manageable chunks. So you will see, as we progress with the detail of estimation methods, we're just adding more detail to the estimations. So the sections are divided into certain elements. So for instance, we're dividing the building into substructures, exterior, facade, roofs, etc. So this is what you would have done in your first year already. So an element is part of any building that always performs the same function, irrespective of its construction or specification, thus facilitating the use of information obtained from the analysis of a building when estimating the cost of other buildings. Elements should not be combined. So very importantly, that's why we use the elemental guide as a guideline so that whoever picks up this estimate can easily see and look at where the cost is derived. So a couple of definitions that we just need to look at. So your elemental method is an estimation method based on an element breakdown of the building. The method involves the use of the element unit quantity and element of rate. So this is basically information that you already should understand. So your elemental cost analysis is a comparison assessment of cost involved in the previous constructing buildings of a similar kind, and it's aimed primarily to providing reliable information which will assist in estimating the cost of future buildings. Then your elemental unit is the unit of measurement that usually relates to the quantity or element components, such as, for instance, the area of your slabs, the number of sanitary fittings, etc. Your rate is then the elemental rate that you're going to use on this calculation. Again, very important to look at comparing apples with apples. So your elemental method on elemental level is, so for instance, if we sketch a scenario, a client contacts you to do an estimate on a new construction project that he would like to undertake. The project entails a new 5-star luxury hotel in Bloemfontein. However, the client asks you to do an accurate estimate using the unit method. Okay. So, and then the little workshop continues. In pairs, discuss how you, as a QS or CM, would explain to your client why the elemental cost analysis method, measurement on elemental level, is a better method to apply to the project to calculate the estimate. So, okay, once you've gone through the work, you can go through the scenario also, because this is a nice question in any test or exam as well. Comparing all of the estimation methods to each other, highlighting the pros and the cons, and being able to debate which method to use, because this is what you're going to do in practice as well. You're going to justify to your client, okay, but at this stage I would propose this method rather than this method because of the information that's available. So looking at some other items that we just need to consider is the elemental method is an approach towards calculating the total estimated cost of the construction project, obviously, in consideration the major elements of a building, and if properly implemented provides a cost estimate based on the elemental breakdown of the project. Any estimate is done strictly according to principles and format as set out in the elemental guide. In order to maintain uniform standard elements where uniform elements were identified which are applicable to all building types. Elemental tariffs are the monetary values applicable to the different elements expressed in terms of the specific unit measurements. Thus, the total cost of a building is calculated from the sum total of all the applicable elemental costs. Okay, still very straightforward. So the purpose of the method is a square meter estimate is easy to compile, but to some extent less reliable, whilst the detailed quantity takeoff is more reliable. Whenever we derive our per square meter rates, it's always based on real projects where we had real quantities that was measured. So we always related to that. So thus your per square meter estimate is only as accurate as the rate that you're using. So the elemental method, a comparison between the relative easy and quick square meter method and a more cumbersome and detailed quantity takeoff is combined. So it is at a high level, you're just breaking your project into different elements to make sure that you have an accurate per square meter rate that you apply to the different sections of your building. So the primary use of this is to enable cost information to be collated and produced in a manner which can assist in the cost controlling of future building projects. Okay, cost control is achieved by preparing an estimate of construction cost based on the information gathered from the analysis in a very early stage of the development, when little or no information is available. Okay, so the important elements, I'm not going to read through this for you. You can go through the important benefits or of the method. So it's a competent, it's basically an improvement. You're just interrogating the data more to get a more accurate apple with apple comparison in your estimation method. So it is all about the accuracy of your quantities, the classification of your quantities, and the rate that you're using that influences the accuracy of your estimate. So far more accurate results can be obtained from different building units when they are priced separately and interrogated separately. So for instance, if you've got um, the squash court, which is one of the examples, and you've got a historical building where you've got wooden floors in the one section of your building, and you want to try and compare those with each other. But maybe that section, for instance, in the example, has a flat roof, concrete roof, so you can't use that rate when calculating your squash court um, building that you're looking at. So you want to take the roof, for instance, of that historical building and compare it with with the relevant roof that you are now aiming to construct. In order to ensure greater accuracy, the different cost units are subdivided further. This is basically what I just mentioned. So the possible applications is it's mainly limited to pricing and estimating. It's not conducive to go out on tender with. So more detailed methods of estimating, obviously. Okay, so very suitable for estimation of buildings from sketch plans that have not been fully developed or primary as your primary document. As we go through the examples, you will see one of the elemental estimates that I'm going to provide you with is one that we did a while ago, where we only had concept drawings. So there was a lot of um, um, considerations and assumptions that we had to make when we did that estimate. But the elemental method still allows you to make those assumptions and base it on previous projects. So it's a very handy tool, but obviously the less information you've got, the longer you will have to take, because now you have to look at the specification first before you actually allocate a rate to it. So just the advantages again: application of interpretation is relatively simple. It's far more accurate, although there are more items. It doesn't take much more time to compile. So if you've got a nice template that you can work from, it can be developed quite quickly. Success at both early and advanced stages of planning, as I just mentioned. The way in which cost information is reflected is extremely easy to interpret. So it's a thing that you can easily discuss with your client over a table. The disadvantages, again, is your historical tariffs are not readily available for all the elements. Some units and measurements can be difficult to interpret and impossible to price. So there you will need to use your resourcefulness. So intricate and time consuming. It can be time consuming. More information has to be gathered and processed. So if it's a method that you've been using over and over again, it's quite nice to actually use it. But if you're first starting out and it's a lot of new items in the estimate, then it does take a bit of time to develop this. So just looking at a practical example, um, we've got a very simple ground floor of an office building, or of a house, where we've got a lounge, a bedroom, one, two, three bedrooms, and then a dining room and a kitchen with one bathroom and a WC on the side. So if you go through your example as per the study notes, you will see this example does pop up, but we'll still go through this in a bit more practical sense of it. So, but it is what you basically did in your first year, where you need to group your elements together. So your elemental element, your foundations, where you have your excavations, your ground floor construction, elemental external envelope, etc. So this is where you guide assists you greatly in developing those different headings and groups that you're going to measure your quantities on. So, for instance, if we look at um, an example of this, a typical example of layout of an elemental estimate, will have your element on this side, your component, and then your description. So just be noteful that this example goes up to component level, and this first elemental method that we're looking at for the single price detailed methods only goes up to your elemental method. But to understand this elemental summary, you need to understand what it comprises of whenever you do it. So whenever you do it on the elemental analysis method, you will go up to this level here. Something that you should also take note of, that this section is basically the elemental guide that is where it's contained in, and then you've got your quantities and your description, your components, which is then described, and then you can have multiple items underneath, for instance brick and block work. So for instance, if you've got a 250 wall, or if you've got a 350 wall, or so, you need to divide it in between here. But it's very simple, very similar to a BOQ, where you have your unit that you're measuring the item in, you've got your quantity, and then you've got your rate that you allocate to it, so that you can calculate your cost. And you will see then this element is then divided into the total cost for this element, so 3.6 million, and if you divide it with the square meters, you get a rate per square meter and a contribution percentage. Okay, so very simple example. Okay, so your analysis method, so you would do this for your substructure. This is your primary elements that you will have here, and your analysis method will go up to this level of estimation. So I'll still try and do this in class a little bit with you, so as soon as you see the practical side of it, it will start making sense. Okay, so getting to our second method of estimation for this week, we look at the story enclosure method. So, it has the purpose of overcoming most disadvantages involved in the previous method. So should specifically make provision for the following cost variables in the unit's measurement. So you plan, shape, and building is considered by measuring the external wall areas, the total floor area by measuring each floor, the height of the different floors are taken into consideration by using different multipliers for each floor. The story heights is included, floor levels below ground level is also considered, and it boils down to you measuring different components and then allocating a factor to it that is then multiplied with a single story enclosure tariff. So you will see the formula is basically the physical area of the story enclosure elements times a factor provides you with a story enclosure area. Then this story enclosure area is then times with the story enclosure tariff, estimating the building cost of an element. Okay. Determine the different areas of all story enclosure elements to which the factor is allocated in order to calculate the adjusted weighted areas. So your story enclosure area is thus calculated. The unit tariff is the story enclosure tariff is allocated to the story enclosure tariff. So it's a repetition of what was said just there. So the total building cost is determined by estimating the following items separately. The additional cost involved in all the structure items finishes and accessories which are not included in the store enclosure tariff. Okay, so external works and so forth. The cost involved in all services items, the cost involved in external works. Okay, the store enclosure area is a weighted area which is calculated by multiplying the area of each of the different store enclosure elements by a pre-calculated factor. Okay, so we're going to look at some of these pre-calculated factors, and then we're going to see if we can improve on those factors. Internal walls were not considered, as these are per definition not store enclosure elements. Okay, so you will see that when we get there. Okay, so the factors that has to be applied. So a factor of 1 is allocated to all floor levels of standard construction in contact with natural ground. And for all floor levels beneath the natural ground, an additional factor of 1 is provided per level. Okay. So, and then we've got a factor of 2 is allowed for all standards suspended floors, and a factor of 1 is allowed for standard corrugated iron roofs and for the concrete and other special roofs with a factor of 2. So you will see in your study notes where the standard factors is provided. Okay, everyone, so here's the factors to be applied. So some of the factors, standard factors that you can use is corrugated iron or asbestos is usually a factor of 1. Your cement tiles is 1.25 and your slate tiles is 1.5. Concrete roof slabs and special roofs is usually a 2. So for all standard 220 millimeter exterior brick walls allow below and above ground, level factor of 1 is allowed, and the factor of 1 is allowed for all standard 220 millimeter thick interior brick partitioning, and 0.5 for 110 millimeter walls. So the total building cost is determined by estimating all of the special and external items separately and allowing for percentage allowance in order to provide the preliminaries and the contingencies for it. So it's the extra over cost basically. So the store enclosure method, so the advantages is it's more accurate than the previous methods. The method is structured in such a manner that it can be used with basically the same degree of success at both very early and advanced stages. It doesn't take up much time, and that's the biggest advantage of this method. And the library of historical factors can be built up quite easily. The downside of it is a large and marginal deviation can have a big effect on the cost. In essence, it's still a single price tariff method and can produce inaccurate estimates also. It's more difficult to use and interpret than the previous methods. So what it implies is basically you need to have ample experience on this method to use it proper. So let's have a look at some of the practical examples. So the store enclosure method, so a residential building, you can see we've got 7 rooms basically for this building, very basic line drawing that we considering. So you go and you break your building up into different elements. So you will have your surface bed, your roof, your 220 millimeter walls, your gables, 110 millimeter walls, and any openings that you want to deduct from those openings. So this is more or less the basics that one will use, and you will see in examples that this is all of your cost is then related to these areas, irrespective of what the finishes is and so on. So if you know that you've got a high-end finish building, then you can adjust your factors accordingly for that. Okay, but the short and the long of it is you get your respective areas and you times it with the factors and you add it up together to get your store enclosure area. And then the BER usually has a set standard for calculating your store enclosure tariff. So you will see in the examples, it's quite old information that we're using there. So you always try and, but the principle still stays the same, where you use your current rates to price and calculate your store enclosure tariff that you're going to use. So we'll still get into that in the next couple of lectures. So this is typically how the calculation sheet looks, and this is what you will use when you're calculating your story enclosure tariff. So these items always stays the same, and you take a historical building to price all of these items to get to a standard story enclosure total, which is then divided by the standard free 357.7 square meters. So very importantly, when you divide this total, it's always by the standard provided here. So you will see an example that's provided is you keep the quantities the same, you only amend the rates to get to your new adjusted store enclosure total tariff that's divided by the 357. Okay, it's just an example of it's based on a standard building whenever you're calculating your store enclosure tariff. Okay, so looking at another example is, so your store enclosure factor for the surface bed of a building is usually 1. But the factor actually varies from building to building, so one wants to improve that factor and consider that whenever you're changing it. So determine the actual factor to be used in the surface bed in the building. We use the following formula. So the formula to calculate the factor of your surface bed is basically if your factor is 0.4 plus your total length of the interior and exterior foundation walls combined, okay, so that's L, divided by the surface bed area, so you calculate your surface bed area as well, divided by the total length, and you times that with your depth of your excavation in meters, and then your height of filling in meters. So we'll still get into that practical examples to do that. And then you add 0.1, you do that calculation first, and then you add your 0.4 to get to your new factor that you can use for your surface bed. So the example, an example that we can have a look at, what is the surface bed factor for single toilet structure of 2 meters by 1.4 meters with a 220 millimeter wall. Assume that the excavations is 1 meter deep and the top of the surface bed is 300 millimeters below the natural ground level. Okay, so it was drawn out quite nicely here. So calculating your length is 2 times 2 plus 2 times the 220 millimeter walls deducted from that side, and then to get to a 5.92 meters. Then the area of the surface bed is 2 times 1.4, and then you basically have everything to calculate your factor. So your depth plus your height is equal to 1 plus 0.2 minus the surface bed area. So you're calculating this the filling underneath. So here, if you've got this filling calculated, you continue to just populate your formula to get to your factor. So it's a 0.4 plus the previous page building area and the depth plus 0.5, so you get a factor of 1.91. So you can see, because this is quite a small building, the foundation factor is of the surface bed factor has a big influence on the cost of your building. Okay, so very importantly, you have to work through the examples 5 in Appendix 2 and the calculations to familiarize yourself and to get some questions out there to actually start understanding it. We'll still do some more examples and explanations as we go along, but to start off with, this is one of the or the first section of your assignment, so you need to be able to understand how these calculations work. Okay, so this is just the store enclosure method, just a show of how you calculate your 220 millimeter wall. So the factor for that, so the 220 millimeter wall has a formula of 0.6 plus the percentage windows and doors over 150 for your building. So it's usually your external walls that you calculate. And then for your interior walls, you usually have a 0.44 plus the percentage doors and borrowed lights divided by 143. Okay, so it's three factors that we can actually improve that we're going to look in this module. So it's your surface bed factor, your 220mm wall factor, and your interior wall factor as well. Okay, so looking at example 5b, calculate the story enclosure factor for the external walls of the building. So it's that same building that we had. So the total exterior wall area measured over the windows, but excluding the openings, is 118 square meters. So we've got 8 windows of 1 times 1.8 and 2 exterior doors of 900 millimeters times 2.1. So you calculate your the percentage windows and over the amount of exterior wall. So you add up basically your windows and your doors, and you divide it by 100 to get a percentage, which you divide by your total wall area to get a percentage of your windows and doors on the total enclosure. And then you just add that percentage to your formula. So this is 0.6 plus the 16 or 15.5% here at the top divided by 30, which gives you a factor of 0.72. Okay. So in summary, the following factors is necessary. So it's your surface bed factor, your external wall factor, and your internal wall factors that you should be able to calculate. Then we get to the parametric system, and as I've mentioned, this is the get out of jail free card usually. And the parametric system is the cost of the selected number of elements are expressed per square meter on plan and added to one another to form a parametric tariff. So the weighted tariff is by multiplying the building floor area with the parametric cost tariff. The parametric cost is calculated, which represents a percentage of the total building cost. Okay, in short, it says that you've progressed up to a point with your calculation, but now you want to extrapolate that to a final total estimate for your building. So you take the items that you've calculated so far, calculate what percentage that makes up of your typical building, and you then add the rest of the items to get to a final cost. So it entails a combination of area and elemental methods for this analysis. And now any number of elements can be selected for this purpose. Okay, so possible applications is relatively unknown and untested, but it does provide you with some flexibility when you're doing an estimate. Exclusive purpose of indicating cost trends rather than providing accurate cost predictions. Okay, and the advantages is it's quick because little information has to be processed, the same as area methods, so the same rationale is usually used. Complex, and it's complex and requires considerable research in order to be able to deduce cost trends only as accurate as the information that you put into this calculation. So the calculation of adjustment factors can be quite complicated if you want to go into that. So let's look at a practical example of this. So the available data is on a historical project is shown in the following table. So what we do is we've calculated the cost data that you have available on the planned project. So you've progressed up to this point with your current estimate. So if you've calculated your foundations, your ground floor construction, your internal wall divisions, your ceilings, and exterior walls. So now from this information, you can calculate your parametric tariff. So all that you do is you add all of these areas together, or cost per square meter together, to get a total for these items. So then you determine the parametric cost tariff as percentage of the basic building cost for the three internal projects. So this is your new building. And then if you go back to that first slide where the historical data is, you actually had 3 projects of similar size. So you take the relevant cost per square meter for those projects. So project 1, the foundations, then you go to the ground floor, the internal divisions, the ceilings, and the exterior walls, and you add them all up, and you divide it with your total cost for that building to calculate how much did these items contribute to the total cost of your building. So in project 1, we could see it contributed to 60%, project 2, 57%, project 3, 63%. Okay, so then you work out the average of this, and it's simply adding the 3 percentages together and dividing it by the number of projects, in this case 3, to get a total percentage of 60%. Then what you do is you take this calculation that you've done here, the 714 Rand per square meter, and then you times it, or you extrapolate it with the 60%. So the extrapolation is basically you want to get to 100% here, and you're dividing it with, you currently have 60%. And if you do that, you can see, okay, the building rate should go up to 1,190 Rand per square meter. Okay, so I've just added 1 or 2 slides here, which is basically the same which I just explained. It's just a bit better quality. So you can just go through these notes that I'll be posting, and you can see the scenario, a typical scenario where you can apply this method. Okay, so here's the 3 projects that I was referring to earlier, just a better version of that. So you will highlight the applicable items that you've done, so foundations, ground floor construction, etc. And this is the basic building cost that you need to divide your building with. Okay, so this is the table that we've shown earlier. This is how far you progress on your new project. You can see the 714 Rand per square meter, and then you determine the costs, just the explanation what I did already. Again, the 3 projects to get to the percentage contribution for those items on the historical projects, and then you calculate the average of that. You then times the square meter rate that you already calculated, you extrapolate that to derive your final basic rate per square meter. Okay, so you can see this is still just the basic one. You still need to add all of your additional costs to it. Okay, thank you very much, everyone. So a very short introduction to the single price detailed methods. Please note that your first part of your assignment will focus on this area. So please make sure that you start going through the examples and also prepare for a possible informal assessment on this. Thank you very much, everyone. Bye.